This video is brought to you by Sporlan, quality, integrity, and tradition. So we got a call that an exhaust fan's not working. Actually, it's that this exhaust fan right here is not working. So I turned all the hoods on. It's early in the morning. I turned everything on, so we're gonna head up top and we'll see what's going on with this fan. Now that we're up on the roof, we have our lineup of exhaust fans right here to right here. We need to find which one's not running. Should be this one, because this is generally over the area, and yeah, it's not running. So we're gonna open up the top, but let's double check to make sure all their other fans are running. This one's making a funny sound. We're gonna have to check these because some of them have belts, some of them don't. And they don't do maintenance here. So, well, they kind of do. So we'll check those too. But let's start with the one that's not working. We'll open this up and have a look at what's going on here. So there's an interesting sound coming from this. Motor's locked up. So something funky is going on here. Now, one thing that's so bizarre about this restaurant, this is the only location of this particular restaurant chain that I have. Every one of these exhaust fans, I believe, is 115 volts, which is insane. They have three-phase power here. There's no reason why these need to be 115 volts. In fact, it's a waste of, it's just inefficient. They should have three-phase. It's just much better, easier to deal with. Single phase, you're dealing with start capacitors and run capacitors. It's just dumb. So this guy looks like it might be locked up. So what we're gonna do is we're gonna turn off power. It just went off on some sort of thermal overload because it was buzzing. And it is locked up solid. That fan is not moving. So we should have a hinge kit on it. We do. So we're gonna go ahead and hinge this guy and see if we can have a look at what's going on here. This thing is locked up. Oh, I just broke it free, but totally bad bearings in that motor. I talk about this a lot, but I'll say it again. I'm not a huge fan of direct drive motors. They're not as easy to change when you have an issue. Now, this particular customer is really good about changing exhaust fans, but this fan honestly is in really good shape. It was changed. I made a video changing this fan like 2 years ago, maybe 3 years at the most, but still, there's nothing, like, this fan certainly could have a motor put into it. One thing that sucks about direct drive though is, like, because there's not a belt, because it's not like a 56 frame that's bolted from the rigid base or something, it's using bolts or nuts on the other side of this. So to get to those, we've got to take a lot of this fan apart to be able to separate it. You might be able to do like a power pack assembly where you just change this bottom section, but it's just a little bit more difficult on direct drive fans to change the motors, and it just kind of adds complexity, especially when they're really greasy. In fact, I had a video on that one over there years ago. That's their fry fan, doing a power pack replacement on it, and it's a pain in the butt because it's all greasy. Now this one luckily isn't that greasy, so it's not a big deal. But we are gonna get some motor specs off this and call around and see if I can source a replacement motor. More than likely I can, because that's just a 115 volt motor. But I need to make sure I can get one. I have a motor supply shop nearby that specializes in motors only. And they do a good job of giving us stuff when we need it. So let's get digging into this. We'll get it pulled apart. We'll see if we can get this motor out and then call around and see if we can find one. If not, like I said, this customer is really good about changing exhaust fans, but it's probably gonna take a couple days to get an exhaust fan versus if I can go get a motor today, I can have this fixed in a couple hours. All right, because this motor was, it was locked up, and then once I broke it free, you can hear the bearing squeaking. I don't necessarily think it's gonna be an electrical issue because it was physically locked up when the power was de-energized, okay? So that's why I'm not jumping into checking the electrical. Now, as I'm disconnecting it, I'll go ahead and check the electrical real quick because I have it disconnected right here. So we're gonna turn this power switch on. And we have 117 volts applied to the unit. It does have a speed controller. Looks like, I don't even know if the speed controller's in use. No, it is. Yeah, speed controller seems to be working. But still, we, like I said, I really didn't see the need to dive into the electrical because it didn't necessarily seem like that had anything to do with my problem. But still something, you know, we'll look at the big picture and we'll check it. But we have it all turned off now, and we're just working on getting this fan apart. From the inside, we'll have to pull these 2 vents right here, and then all the bolts from around the side of it, and then we'll probably pull the whole power pack assembly off as an assembly. Something that I'm noticing, it's all about big picture stuff here, paying attention to what's going on. Do you notice all the oxidation or corrosion, that white stuff? That is the chemical that they use to break down the grease when they're doing exhaust fans cleanings, okay? And if we look, you can see it's in here too. It's all in here. Now, we don't necessarily see it around the motor surfaces necessarily, but that cleaner is probably not good for motor bearings. If they're being as careless with the cleaner as they are on the outside of the fan on the inside and getting it on the shaft of the motor when it's hinged and letting it drip down into the motor, that could cause bearings to go bad. If it breaks down the grease that's on the outside of the fan, it could break down the grease that lubricates the bearings too. It could penetrate into the bearings and cause motors to go bad. Oftentimes you pay attention and you can see that kind of stuff, right? So another thing, now we did just have rain here this weekend, but not a lot. We just had a little bit. If we come over here to their drains and we look, we notice that there's fresh rubber gloves on the ground. And look at that. We have grease in the drains. And over here too, we have grease in the drains. That, to me, implies that they just had these fans cleaned. And if we look at the ground, we tend to notice that there's a lot of really clean areas right around these exhaust fans. I think that these exhaust fans were just cleaned. And I think that during the cleaning process, they got that chemical that they use to break down the grease. What they do is they use a chemical that breaks it down so they can run it down the drains. But I still don't like that idea because look at it. It's not breaking it down completely. That's grease. Like, it's crazy. So, you know, that kind of stuff, the investigation like that helps you to understand the why as to potentially why motors go bad. Now, I'm not going to like tell the customer that, you know, this is why the fan went bad definitively but I'll just give them facts. Hey, there's a lot of the oxidation looking stuff from the stuff they use to break down the fans, and let them come to their own conclusions instead of me pointing fingers. I don't want to point fingers, and I can't guarantee that that's what killed this motor. It looks a little suspicious, kind of, you know? So those are things we all pay attention to when we're looking at exhaust fans. For whatever reason, this exhaust vent right here doesn't have anything holding it in, so we pull that out, okay? But the other one has a cotter pin holding it in. So I already bent the cotter pin back. We're gonna try to get it out. I don't know, actually, to be honest with you, because look at how damaged this cotter pin is on this side. Someone squeezed it the wrong way. That's odd, the way that they did that. So, yeah, this one's doing the same thing. But essentially, we need to get this tube out. So I'm gonna have to pull those cotter pins out. So I gotta get in there and kind of try to squeeze those so that way you can pull it out as one piece. You gotta be calculated about how you take these out because I reuse them. If it was like a critical piece of equipment, maybe I wouldn't reuse them because I don't think they're really meant to be reused, but I'm not gonna replace the cotter pin just for something like that. It's not a safety thing or anything. So now I got it out, we'll pull it out. We got this guy flipped over. This is called sometimes the manufacturers will call this a power pack assembly because sometimes, like with captive air, you can order a whole power pack assembly and it comes with the motor, the wheel, and the base plate. It comes put together. Now, we're not gonna find one of those today, but yeah, this guy's just jammed up. Gets stuck. So anyways, we put some penetrating oil on it. We're gonna let it sit for a minute. Then we're gonna loosen up these set screws and we're gonna try to separate, there's 2 of them, this wheel from this shaft so that way we can get the motor out. So that way we could potentially take it over to the motor shop to see if they have a replacement for us. Loosen the set screws, but I didn't take them out. There's no need to take them out. That's just potential to lose them if you do that. I just loosened them 1.5, 2 turns, so that way they're completely moved away from the shaft. I put penetrating oil on there. We're going to get some sandpaper. We're gonna sand up this shaft all the way up because this wheel has to come off of here. The other thing that's worth noting is pay attention to the distance from this hub or from this base plate that the wheel is, because we potentially have the opportunity to move that wheel up or down. You don't necessarily want to pay attention to the shaft, how far it is from here, unless we get the exact same motor, because it's a possibility that we're going to go and get an aftermarket motor that's not identical to this one, and the shaft might be longer or shorter. So if you assume that you're just going to look at the difference from the shaft to the hub, well, that could be wrong, because the new one could be longer. So something that's not going to change is going to be the distance from here to here. And that's really important, because that's how this piece right here sits in this cone on this exhaust fan. You see the cone right there? And you want it to sit in that appropriately, so that way it can pull the stuff. You don't want it to be sitting too high or too low. Too low, it might hit. Too high, you know, it might recirculate air from the fan itself instead of pulling it from the ducts. So those are all things to consider. So I'm waiting on some sandpaper, and then we'll try to pull this guy off. Now, pulling this off, more than likely, all that I'm gonna have to do is put a crescent wrench right here and spin the wheel, holding the shaft with the crescent wrench back and forth as I slightly lift up on the wheel, and the weight of the motor typically will pull the motor out of the hub, essentially, if it all goes well. If it doesn't, we might have to get a puller or something, who knows. So what I did was took a big piece of sandpaper and stripped it, just pulled it straight down to where it's long like this, and then all that we're doing is getting in here and keeping our fingers about 2-3 inches back. That way we can sand the shaft all the way around, and it does a good job. And just keep moving to the other side, getting it nice and shiny clean, because cleanliness and the penetrating oil is what's going to pull this thing off. Okay, so let's hold on a sec. And all that I'm going to do is put this guy on the shaft, and we're going to see if we can get it to break free. Ooh, and it's not breaking free. Ooh, yeah, it's tight. Okay, so here's what's happened. Right over here, there's 2 set screws on this guy. There's one that goes to the flat right there, and then there's another one that goes to the rounded part. And that set screw is there to basically ensure that if this one comes loose, that this one's going to be there to back it up. Well, what happens is when you tighten that set screw, this one right here, and you run it in, you actually scar the shaft, which is the purpose of it, because it shouldn't be coming off, but it makes it hard to take it off after the fact. I'm not a huge fan of these. If this one is set right, it's not going to back out, but they do this as a precautionary thing. So more than likely, the scarring in the steel shaft on this one is what's holding us up. As I'm going through this, I'm realizing there's a pretty big space underneath here. So I'm using that same sandpaper in the same way to clean this like this. So I get down here and I'm just running it and carefully letting it spin, because one method of this is potentially and carefully pushing the wheel down on the shaft carefully enough to expose what we need to get the whole thing out, possibly. We'll have to see right now. But so I'm going to sand it, get some more penetrating oil on it, and then we're going to go get some tools to try to separate this. Now, some other ideas that I have is potentially using airbags, because I do have little inflatable airbags that we can put under here that'll put pressure to help push the wheel up. But you have to be very careful, because this is aluminum and I can bend it with my hands. So we don't want to damage anything under here. This can be tricky, but this guy's kind of a pain in the butt to get off. That's how it is though. So it is what it is. So we're gonna go down and get some supplies from the van. The first thing I'm gonna try is using the airbags. So I brought 4, but I realized this one's actually broken. Look on the top, it won't hold pressure. So we're gonna attempt to do this with 3. So I put it under there carefully without damaging the turning vanes, and we're gonna start applying pressure. We're pumping it up, and we're just getting that pressure on it evenly. So start pumping that one over there, and we're just evenly pumping it up. We already measured this. It's 1.5 inches from the factory. But remember, like I said, we gotta be careful. This is an aluminum wheel. You could very easily bend it, and we don't wanna do that. So we're just applying pressure evenly, and we're gonna keep doing that in hopes that it pops. All right, the airbags didn't work. So we have another solution. I grabbed a small piece of EMT from the van. It goes directly over the shaft, and we're able to hit on the inside of the hub. I put it on a brick so that way we're not damaging the TPO roof or the equipment, and we're hitting it down very carefully to expose the damaged section. You can see we're already moving it down about 1/4 of an inch. But we gotta pay attention. We don't want it to get to the point where these little turning vanes or whatever are hitting anything. So we don't want to damage anything, but we need to go down a little bit, and the hopes are that we expose the damage from that set screw so we can sand it up and then potentially pull it off. Anytime you're working with a shaft like this, when you're hitting on it, you can damage bearings, right? So that's something to consider. The next thing is you never want to hit on the shaft, because look at, I've been hitting on this EMT and I mushroomed it out. You can see how it's coming out. That's from hitting. The same thing would happen to that shaft if we were to hit on it. So we were able to move this down to the point that, look at, we've exposed, let's see if you guys can see this. We've exposed the spot where the set screws were at. We look right here, you can see this is the damaged section right there. That little bit, you'd be surprised, does a lot to hold that thing on. So now we're gonna sand it up really good and clean up that little scarred surface, and then we're gonna attempt to spin this again with the crescent wrench and the penetrating oil, and then potentially spin it off the shaft. So we cleaned it up, we fixed the damage area, and now what we're gonna attempt to do, let's see. I cleaned it really good, now let's see if we can get it to spin. Boy, this guy is just, there we go. Ugh, it's not happy though. Oh man. Might need to heat it up. Getting on here with a puller is not going to be very practical. There's nowhere to really put the puller. You got to be careful too what I'm doing. This is a sharp edge, so if I slip, you know, don't want to hurt yourself. It's turning, but just not very much. All being careful because this is an aluminum wheel. We're not damaging the aluminum wheel either. It's turning, just, there we go. There we go. The more you turn it, the more it's gonna break free what's in there. It's getting the penetrating oil into the spots that it needs to. We're just letting it sit for a minute, and this thing should come off here in a minute. First, this guy wasn't spinning, and what I started to notice is it starts to damage the shaft right in here from the crescent wrench, because the crescent wrench isn't the most ideal thing. So paying attention, you can kind of sand that out, but know that once we get it moving, we're gonna have to do some work on this to clean up that shaft. But the idea is that the more that I get this to spin on there, and it is breaking free, the more penetrating oil gets in there, lubricates the shaft. So have a look. Now this motor has a lot of weight to it. So what I'm gonna do is actually very carefully, as I'm spinning this, I'm gonna lift up on the wheel very carefully in hopes that the weight of the motor starts pulling the wheel up. So now you can see that it's actually spinning pretty freely because I've broken it free back and forth, and then as I'm doing this, I'm just kind of lifting up, and we're just slowly lifting to the point that now you can see that we're free spinning. So this thing probably is getting pretty close to being able to release. And it may be easy with the airbags now. We might be able to get the airbags in there and just pop this thing up. All right, what we did was we got it to move down enough to where I could get the crescent wrench on the bottom side of the shaft. Then I have two people here. One person lifted from this side, I lifted on this side, just holding the bottom of the wheel, and we let the motor weight work. As I was spinning it back and forth, the weight of the motor pulled it out, and this popped right off. So I don't see any damage to this. This looks like it's in good shape. We were very careful. We tried the airbags to separate it, but it didn't work. So now you can see why I don't like direct driven motors, because we had to access all that to be able to get to these. So it's not even just pulling the wheel off, because some exhaust fans you can pull the wheel off from the bottom side. You got to get to these nuts to be able to separate that motor. We don't know if we can get this motor today, and we can't leave this exhaust fan open because it's potentially going to rain. We don't want that going down in there. You got to think big here. So we're going to go ahead and put the fan back together just loose, all the pieces, the cone and the lid. That way if it does rain, the water goes down the natural path and then comes out the drain. See, these fans are designed to be outside in the rain, so, but only if you have all this back together. Now I'm gonna have to take this motor over to the motor shop. It is on the way back to the shop anyways. We don't know if they're gonna have it, but there's a few things that are peculiar about this motor, whereas normally I would just call and be like, do you guys have this motor? I don't know if they're gonna have it or not. We had all the nuts and bolts set up right here for the fan to put it back together. But like I said, there's potential it's gonna rain, so we moved it so that way it doesn't wash down the drain and then give us a bad day. So we put everything over here in this AC. We put this fan back together so that way if it rains, it's not the end of the world. And this is all sitting right there, nice and safe. So that can get wet, but it's not gonna, you know, come out of that. So that'll be fine. Everything's good, power's turned off, wires are isolated. So we are gonna pick everything up and take it, just in case we can't find the motor and we have to come back another day. We're not gonna leave stuff up here and leave the roof in disarray. Always, the way that I always do this is, if you assume the worst, you can only be satisfied, kind of a thing, within reason, right? So what happens if we get a torrential downpour and all that stuff goes down the drain? That's gonna be a bad day, so just move it, you know? Make that not part of the equation. So we're gonna head to the motor shop and see what they have. Well, we were able to find a motor. It is a little bit different. The specs are all good, but it's just a little bit of a different motor, but the shaft size is the same. We ended up putting an electrical box because there's not a built-in electrical box on here. We are wired in. We got to check the rotation because it is reversible. It's 115 volt. So we're going to check that, and we're allowed to run 9.8 amps. So we need to make sure we're not over amping. So 1, 2, 3, please don't blow up. Okay, so first and foremost, the rotation is correct. You got to be careful. Don't want to hurt yourself. It can be sharp sticking your fingers in here, but I can tell. The camera won't. See, to you guys, this looks like it's spinning this way, but it's not. It's spinning the correct rotation, the shutter speed or whatever it is, and the camera messes with that. So rotation is correct. So now we just need to make sure we're not running too high of current, and then set the speed. The speed on this guy was about right there, but we'll set the speed too. So here we go. Give it a second. It's kicking a bunch of stuff out. We got to let it kick its stuff out. So we're right at current, 9.8, and I can slow it down a little bit. So I want to go full speed because I want to see what happens. So I want to see what happens when we go full speed, what the current goes to, just out of curiosity. Actually, at full speed, we're only at 8.27 amps. You guys can't see, but we're more than plenty. And then as we slow it down, that's when this speed controller starts acting wonky. Current goes up 10 amps. Yeah. So this motor, we're gonna run it at a higher speed. Yeah, these speed controllers can be really wonky on motors sometimes. So we want to make sure we're not over amping. Let it run for a minute. We're right at about 8.7 amps at the moment, and it's running in the right direction. So we're good. That's about where we're gonna keep it right now. Yeah. So we are doing good. I'm not a huge fan of these speed controllers, but you know, you need them to air balance these fans. So I prefer 3-phase or a pulley because you can slow it down and speed it up via a pulley. But on a cheap fan like this with a cheap 115 volt motor, this is all that we have, is this stupid rheostat style speed controller, whatever it is. They're just not very high quality in my opinion. But we are not over amping. We're running in the right direction. So we're gonna shut it off for a minute, and we're just gonna button up some things. We gotta button up that electrical box right there and clean all this stuff up to make sure everything else is good. All right, this guy is all put back together. Everything's good. We also dated the motor, today's date. Right Supply is the supply house we bought it from. Everything's good, going in the right direction. They now have a functioning exhaust fan, all is well. We're gonna put the lid back on and tell them to keep an eye on it.
I try my best to use this step-by-step approach when I'm completing almost every one of my service calls. I take the time to, you know, double check and be thorough when I'm going through things. You know, measuring, verifying as you're taking things apart. Take pictures, you know, like for instance, not associated with this video, I was changing a duct detector today and it was a really weird one. And the wiring was really wacky. So the whole time I'm writing everything down. That way, in case I lose a wire or something comes unwired, it's like, oh yeah, I took pictures. I know exactly the way it came apart, right? Again, I use that motto within reason, always assume the worst, because if you assume the worst and prepare for the worst, then you can only be satisfied, right? I mean, it's not that big of a deal when everything hits the fan and you are ready for it. So, you know, pun intended there. But, you know, taking the fan apart, really important is, you know, don't just measure the shaft coming out of the hub, because like I said, the replacement motor might be different. Even if you order an OEM one, they might send an aftermarket or they might send a retrofit motor. Things change. So, you know, think that stuff through when you're disassembling the fan. It's really important, and it'll make your day so much easier. Nothing worse than getting into a situation and then you're like, oh man, what do I do? And then it just becomes really difficult. So within reason, I always assume the worst, right? You know, I really appreciate you making it to the end of the video. Thank you so very much. You know, these videos, it's so crazy to think that you guys all watch this. I'm nearing on the channel almost 200,000 subscribers. Like I'm like less than 10,000 away from it. And it's really interesting because I never planned on any of this. Now, I'm not going to lie. These videos are getting boring to me. They really are. Like it feels like it's the same thing all the time, like editing these, and the amount of time that I spend in this office, it just gets frustrating, right? At times I spend a lot of time editing, and don't get me wrong. You know, I make money from this. Like I'm thankful for it and all, but like, the point that I'm trying to make is that the comments, when I read the comments, when I see that these videos have helped someone, you know, that really does make it better. It makes it more worth it. So thank you so very much for those that do leave feedback. And, you know, I appreciate feedback, negative or positive. I mean, if you feel like, you know, you could have done it better, if you feel like I did something wrong, I'm always okay with those comments. Let me know in the comments. You don't got to be a jerk about it, but give me the feedback. I mean, maybe I can learn something. I'm always looking to learn. I'm always looking for new ways, new tools, new ideas. Let me know. I mean, do you have a different way that you would have done this motor? I know some people will say, well, I would have just cut the shaft off with the Sawzall. Okay, that's a great idea, but then we have another issue. Now we got to get it out of the thing. And I don't carry a press in my van, right? So, but I'm always curious, like, how would you have done this differently? Let me know down in the comments. If you guys haven't already, please consider going to my website, hvacrvideos.com. It's a great way to help support the channel. We have merchandise available on there, hats, beanies. Those are the two #1 sellers. We do have sweatshirts and t-shirts, but the sweatshirts and t-shirts at this time right now are slowly being phased out. So get them while you can, because I don't know when and if they're going to be back in stock again. They just don't move very much, and we stock all the merch items at my house, and it's just taking up too much space. So we're going to try to more or less keep the stuff that actually sells. That way, when we do fill up the room, we actually moved all the merchandise out of my office because it was just overflowing in here. Like, it was just insane. So we took over the garage. We have a garage room that's, you know, finished and whatnot. And that became our merch shop, basically. So it is very, very awesome. I never planned on any of this. So thank you all so very much for all your continued support that you have, and potentially in the future that you give. It's very awesome. You know, the easiest way to support this channel, though, is literally just watch these videos from beginning to end. That really is the easiest way. Couple other methods. You can donate to the channel via PayPal. That's just like you choose the amount, donation, whatever, so be it. There's links in the show notes to all these other methods I'm going to mention right now. You can also donate to the channel via Patreon or YouTube channel memberships, which are just ways you can make monthly commitments to the channel. You know, if you're interested in purchasing any tools, you can go to truetechtools.com. They have lots of great tools and different stuff on their website, and I actually have an affiliate code set up with them. If you use my affiliate code, you get a discount at checkout, and then I get a small commission from that. So it's a great way to help support the channel. The affiliate code is big picture, one word. Really easy. So those are all great ways. But again, the easiest way is literally just watch the videos from beginning to end. That is the easiest way. It just costs you a little bit of your time. Doesn't cost you anything. But it's also humbling. So thank you so very much. I really do appreciate it. And yeah, we'll catch you on the next one.